Good morning. So I wasn't able to be there today to go over our test review, but again, we do have a lot to cover. So let's take a quick look at the first two questions of the test review. So starting off, this first set was solve each system of equations by using row operations. So we need to get our system of equations into a modified matrix. So we're going to rewrite this as a matrix. And we're going to take the coefficients from each one of those values plus the constant that was set equal to, and those are going to be the numbers for our modified matrix. So we have 2, we have 5, and we have -4. Then we have 4, we have -1, and we have 14. Again, we're putting a line here where our equal sign would be. So again, each one of these values over here to the left represent the coefficients of our x's, of our y's, and then on the right side, those are our constants that they were set equal to when this was in standard form. So now that we have it in a modified matrix, we are going to have to use some row operations to get this into what we call row echelon form. So we have to have, again, 0 in this bottom left corner. We have to have positive ones going diagonally. Where the 5 is, that could be any number, it doesn't matter what it is. And then once we do that, we'll be able to pull it back out so that we have two brand new equations. So first thing, we want to get rid of this 4. There are only certain row operations we can do. Again, the row operations we had are multiply a row by a number. We could also change the order of the rows, or we can multiply a row by a value and then add it to another row. In order to get things to cancel out to become 0, the only way to do that is to multiply a different row by a number and then add it to another row. So this 2, if we multiply that 2 by -2, it'd become a -4. And when adding it to 4, it'd get that to cancel out to become 0. So that's what we're going to do here. We're going to start off by taking row 1 and multiplying it by -2. So -2 times row 1. And then we're going to add it to the second row. So I'm going to rewrite this modified matrix. The top row is not going to change at all. So I have 2 and 5 still. And I also still have the -4. On the next line, so we're taking the 2 from the first row, multiplying it by -2, so it's -4, adding it to the 4 on the bottom, so that's 0. Then we're taking the 5, doing the same thing, multiplying by -2, that's -10. -10 plus -1 is -11. Then we're going to have the -4 times -2 gives us a +8. +8 plus 14 is 22. So now we have 0 in the correct place. In order to make this row echelon form, we need these two diagonally to both be 1s. Again, the way that you get them to become 1s is by multiplying those values where we need the 1s by the reciprocal. So this 2, in order to become a 1, we'd multiply by 1/2. So row 1, we're going to multiply by 1/2. In order to make the 11 a 1, that's a -11. So we're going to multiply by the reciprocal of that, which is -1/11. So row 2, and multiply by -1/11. And I'm just going to do these both in the same step just to save a little bit of time. So rewriting this, we have 2 times 1/2, which is the same thing as divided by 2. So that gives us 1. 5 times 1/2, or divided by 2, is 5/2. -4 times 1/2, or divided by 2, is -2. On the bottom, 0 times any number is still just 0. -11 times -1/11 becomes +1. And then 22 times -1/11 becomes -2. So we have our two values of this matrix. This matrix is now in row echelon form, and we can pull these values back out to make two brand new equations that are much easier to solve. So we have the top one becomes 1x or just x. Then we have 5/2 is going to be the coefficient that goes in front of the y value. And then we have equals -2. On the bottom, 0, that's our coefficient for x, so there is no x value. The 1, that's our coefficient for the y, so just y, equals -2. So we already have half of our answer. We know what the y value is. The y value is -2. We need to take that and plug it back into the first equation to find the other half of our answer and get our x value. So x plus 5/2 times our y value of -2 equals -2. Well, first thing that we can do here, we have 2 and -2. Those two are going to cancel out, and we're going to end up with a negative for this value, though, because we're multiplying a positive and negative. So this is x minus 5 equals -2. We have to now add 5 to both sides. So x is going to give us +3. Because again, -2 plus 5 is +3. So we have an x value, we have a y value. So our solution to this is 3, -2. We're going to write it as an order pair. Okay, so for number 19, same thing. We have ourselves our modified matrix. We're going to plug in the 6, the 3, the 9, the -7, the 2, and the 17. Now, a little bit different than on the last one. I would actually choose to make those top numbers a little bit smaller so that it was an easier problem to do. So, for example, on the top here, every single one of these values is divisible by 3. So if I multiply the top row by 1/3, I can make those numbers a little bit smaller, and it's going to be easier to work with in the end. So I'm going to change that to 6 times 1/3 is just 2. 3 times 1/3 is 1. 9 times 1/3 is 3. Now on the bottom, we still have -7, 2, and 17. Now, I also still think that this problem is a little bit harder than the last one because there's nothing that I can multiply 2 by to make it 7, or there's nothing, so I can't just get rid of this 7 like I could on the last problem. But what I could do is get this to another number that 2 would go into first. So kind of the same way where you multiply a system for solving by elimination, so that you multiply the top equation and bottom equation by 2 different numbers so that you have a pair of numbers that cancels off. Kind of the same idea here. You have the -7. If I get this to become 14, then I can multiply the top number by 7 so that I'd have a +14. So when I add them together, they cancel off. So I'm going to go ahead and multiply the bottom equation right now. So row 2 by 2. So we have 2, 1, and 3. Now this is not the only way to solve this, but by multiplying this by 2, yes, I'm making the bottom number slightly bigger, but now I'll get a nice whole number that I can multiply the top row by to get the bottom number. Otherwise, I might be multiplying by a fraction and it might look a little messy. I'm trying to keep it as clean as possible. So if I take now the top row and multiply these by 7, I'll get a +14, which then I could add to the bottom and cancel out. So I'm going to take row 1, multiply it by a +7, and then add it to row 2. So let me just rewrite this. 2, 1, and 3 on top. 2 times 7 is 14. Add to -14, that's 0. 1 times 7 is 7. 7 plus 4 is 11. 3 times 7 is 21. 21 plus 34 is 55. Now, this isn't quite row echelon form yet, but if we get the 2 to become a 1 and 11 to become a 1, then we'd be there. So top row I'm going to multiply by the reciprocal of 2, which is 1/2. And bottom row, I'm going to multiply by the reciprocal of 11, which is 1/11. So now we have the first one. 2 times 1/2 is just 1. 1 times 1/2 is 1/2. 3 times 1/2 is 3/2. On the bottom, we still have 0 because 0 times any number is still 0. So 0 times 1/11 is still 0. 11 times 1/11 is 1. And then 55 times 1/11, again, 55 divided by 11 would be 5. So we have our row echelon form. We can rewrite these equations, which, although we have a few fractions, it's not too messy. So the top one, this is like we have 1x, or just x. 1/2 y is equal to, 3/2. On the other equation, again, 0, so there's no x value. 1y, or just y, equals 5. So we already know what half of our answer is. We have y equals 5. On this top one, we're going to go ahead and plug it in. Now, you could choose to plug it in first, or you can make it look a little nicer. I don't like the fractions that are there. So I'm going to go ahead and get rid of those fractions. I'll go ahead and plug in the y value first before I do that. But I have 1/2 times 5 equals 3/2. Again, that was a 3 on top. That looks a little messy, but that's a 3 up there. I don't know if that's any better. So 1/2 of 5. Again, if you're to multiply that, that's 5/2 equals 3/2. If you want to, since the denominator is the same on both of these, it's not too bad to just go ahead and subtract. So I guess we don't have to get rid of the fraction. So if we subtract that, 3 minus 5 is 2. That's a negative. So I get a negative 2 over 2, which is 1, or -1. So my answer here, I have an x value of -1, a y value of 5. Oops, I didn't mean to write that. So together, that's -1 and 5 for my final answer. What I was originally going to say up here is if I wanted to make this a little bit nicer to work with, if I didn't want fractions, I could multiply everything by 2, which would end up giving me 2x plus y equals 3. And if you did that at the beginning, you wouldn't have had to deal with any fractions until the end. Again, whether you want to do that or not, that's up to you. All right. Next. On 22, find the value of each variable. So remember, if you have two matrices set equal, that means that the same corresponding positions have to be equal. So for A, that one's a little bit easier. We have the 5 and the A in the same spot. So A is equal to 5. Now, for the next one, we have x plus 2 is equal to 3x minus 1. So you'd have to actually solve by setting those two equal to each other. So we can bring this x over by subtracting it. So we have 2 equals 2x minus 1. Add the 1 to the other side. That's 3 equals 2x. Divide by 2. X is 3/2. For the next one, well, the z is easy. It's just 9. The y, we have those two. Oops, where'd my pen go? There it is. This one and this one. Negative 6y equals 5y. Well, on here, if you subtract no matter which one you subtract, we're going to have, let's go ahead and get rid of the 6y. We're going to add 6y in order to get rid of that one. So that's going to give us 0 equals 11y. Divide by 11, 0 equals y. So those are 4 answers for number 22. Now, number 23 is essentially the same thing, a little bit more challenging because, again, they have addition between the two matrices, but the matrices are the same size matrices. We have 2 by 3 matrices. So the two values that are in the same positions in the first two have to add up to give us the one in the last matrix. So let's change the ink one more time. All right, so let's go with, so this one here plus this one here equals this one here. So the top left in all these are the ones that go together. So -6 plus k plus 3 minus 2k equals 5. Combine like terms, -6 and 3 gives us -3. Positive k and -2k gives us 1k, or just k. Then bring the 3 across by adding it, and k is equal to 8. The next value. All right, we got 2, 5, and y. So 2 plus 5 equals y. 2 plus 5 is 7, so y equals 7. All right, the next one, got a value, a plus 3 plus 7 equals 6a. So again, writing that out, a plus 3 plus 7 equals 6a. Combine the two like terms, 3 and 7 gives us 10. Get rid of the a by subtracting it, so 10 equals 5a. Divide by 5, and a is 2. All right, next, the m's. So the bottom left position there, -2 plus m plus 5 equals 2m. Combine like terms, -2 and 5. That's going to be positive 3. Bring this m over the other way by subtracting m. I end up with m equals 3. And that's it. On the next one. So we got 3p, we got 8p, and we got 11. 3p plus 8p equals 11. 3p and 8p is 11p. Divide by 11, and p equals 1. And finally, the last one here, we have 2r, 5r, and -35. So 2r plus 5r equals -35. 2r and 5r add up to 7r. Divide by 7, and r is -5. Okay, moving right along. On the next set, so again, more operations with matrices. On number 24, we have a 3 by 1 matrix that we are subtracting, and then another one that we are adding. So for each row, we should end up with the exact same size matrix, because again, in order to add and subtract matrices, they have to be the same size, and then their final answer should also be the same size. So for the one where we have the subtraction, this is essentially going to be distributed to each of the values in here, and we can change that to plus. So this is going to be -8, +4, -6, change that to a plus sign. So on top, we have 3 plus a -8, that's -5, plus 1, that's -4. In the middle, 2 plus 4 is 6, plus 0 is still 6. 5 plus -6 is -1. -1 plus 2 is +1. And that's our answer. On 5, there are 2 operations here as well. There's a 4 out in front. This is a scalar multiplier. So that has to go to every single one of those values. So that 4 is going to go to every single one of the values in the matrix. So it's like a really big distributive property. So 4 times 3 is 12. 4 times -4 is -16. 4 times 2 is 8. 4 times 5 is 20. 4 times -1 is -4. 4 times 6 is 24. So that's our first matrix. Now, both of these matrices are the same size. So we can go ahead and add these two together. So adding the corresponding positions, 12 and 3, sorry, 12 and -3 is going to be +9. -16 and 2 is -14. 8 and 5 is 13. 20 and 1 is 21. -4 and 0 is -4. 24 and 4 is 28. All right. Again, still doing the same thing. So doing the different matrix operations. On number 26, we have another subtraction symbol. Again, distribute it, changes to addition. So this would be -3, -4, -1, -7, and this becomes plus. Now, can we actually do this problem? Well, we have a 2 by 3 matrix, and we have a 2 by 2 matrix. So 2 rows by 3 columns, 2 rows by 2 columns. They're not the same size. We cannot combine these. So we cannot add or we cannot simplify. All right, and so not the same size. Be. All right, so not the same size, can't be combined. Number 27. Now we're multiplying. Now, when we multiply, if it's multiplying 2 matrices, again, we're doing the row by the column. All right. So for the first one, we have -3 times -1 plus 4 times 2. So -3 times -1, +3. 4 times 2 is 8. 3 plus 8 is 11. So top corner is 11. On the next one, so still doing first row, second column. So -3 times, again, we're multiplying by the second column now. -3 times 0 plus 4 times 5. -3 times 0 is 0. 4 times 5 is 20. So that other top corner is 20. Now moving to the bottom. So now we're doing the second row times the first column. So 2 times -2 plus 8 times 2. 2 times -1 is -2. 8 times 2 is 16. Add them together and you get 14. On the other one, so again, second row, second column. So we have 2 times 0 plus 8 times 5. 2 times 0 is 0. 8 times 5 is 40. So that bottom corner is 40. So again, those are our matrices. That's our final answer for that one. Now, the matrices don't have to be the same shape or same size when it comes to multiplying. So we're going to look at one more where they are the same size, but then we're going to look at a couple that aren't the same size. So number 28, we have, again, still a 2 by 2 and a 2 by 2. That's all right. We can do that. That's very similar to the other one that we just did. So multiply first row by first column. So actually, this is going to have to be a little bit bigger. All right, -1 times -3 plus 0 times 2. That's +3 plus 0 is 3. Then we have, on the next one, -1 times 4 and plus 0 times 8. -1 times 4 is -4 plus 0 is going to be -4. In the next position, 2 and 5 times -3 and 2. 2 times -3 plus 5 and 2. 2 and -3 is -6. 5 and 2 is 10. Together, that's +4. Then we have, again, second row, second column. So 2 times 4 plus 5 times 8. 2 times 4 is 8. 5 times 8 is 40. And together you get 48. All right. The next one, it's not the same size. So here we have a 3 by 2. This is a 2 by 2. In order to combine matrices, the number of columns in the first one has to match the number of rows in the second one. So if I write this out as to the type of matrix it is, this is a 3-row by 2-column matrix. The second one is a 2-row by 2-column matrix. Again, these are row, column, row, columns. If these two numbers are the same, again, they can be multiplied. And the type of matrix they end up producing will be found by the outside two numbers here. So the rows from the first and the columns from that. So our final answer here should look like a 3 by 2 matrix. So it should look similar to the first one out of these two. So again, every row has to be multiplied by each of the two columns. So it's going to be a little bit bigger. And our final thing, I'm going to draw down here as well. So we have 1 times 4 plus 2 times -1. Again, that was the first row, first column. 1 times 4 is 4. 2 times -1 is -2. 4 and -2 is +2. Moving on over, first row, second column. 1 times 8 plus 2 times 2. 1 times 8 is 8. 2 times 2 is 4. Add together and you get 12. So we have 2 and 12 so far. On the next line, so now we're doing the next row. Let's keep going down. 3 times 4 plus 0 times -1. 3 times 4 is 12. 0 -1 is 0. So that is 12. On the other side, 3 times now the next column, 8 plus 0 times 2. 3 times 8 is 24. 0 times 2 is 0. So that's 24. Then the last row, negative 6 times 4 plus 5 times negative 1. Negative 6 times 4 is negative 24. 5 times negative 1 is negative 5. Negative 24 and negative 5 is negative 29. And then finally, the last one, negative 6 times 8 plus 5 times 2. So negative 6 times 8 is negative 48. 5 times 2 is 10. Negative 48 and a positive 10 gives us negative 38. So again, this is our final matrix for that one. All right, one last one. So again, can we actually combine these? Well, the first one is a 2-row by 3-column. The second one is a 3-row by 2-column. So again, these two are the same. They can be multiplied. What is it going to look like in the end? It's going to end up being a 2 by 2 matrix. So we have first row by first column. Three times negative 2 plus 2 times 0 plus negative 1 times 3. That's going to be negative 6, 0, and negative 3. Total of negative 9. So in my new 2 by 2, that first corner is negative 9. Next one, 3 times 0 plus 2 times 2 plus negative 1 times 1. That's 0, 4, and negative 1. Total of 3. On the next line, so now second row, first column. 4 times negative 2, 0 times 0, 6 times 3. 4 times negative 2 is negative 8. That's still 0. This is 18. 18 and negative 8 gives us 10. The bottom corner is 10. Last spot, 4 times 0 plus 0 times 2 plus 6 times 1. That's 0, 0, and 6. So that one is 6. Again, final answer. All right, so those are multiplied matrices. The last part, I think I actually spaced that out fine, but all right, on 40 and 41, they had evaluate each determinant. So for this one, we needed to do our determinant, which we can do by taking, if it's in the setup, A, B, C, D. What we're doing is A times D minus B times C. So in the first one, again, this is A, B, C, and D. So we have A is negative 2 times D is 3 minus C 0 times 4. So A, D, and it doesn't matter which one you do as B and C. Again, they're going this way, so the order didn't matter there. I know I put them slightly out of order. It should have been 4 times 0, but again, same idea. So that's negative 6 minus 0, which is negative 6. That's my determinant for the first one. For the second one, again, A, B, C, D. So A and D multiplied together, so negative 1 times 9 minus B and C together. So that's 8 times 2. So this first one is -9 minus 16 gives us -25. That's for our second determinant. All right. Yesterday in class, we did a couple problems with our inverse, identifying whether or not something was an inverse. It looks like I forgot to add any inverse problems in here. So just to recap on that one, in order for something to be an inverse when multiplying, if it's a 2x2 matrix C, when you multiply it, they would have to end up giving you something that looks like this. Oops. I want this to be a matrix, not a determinant. Again, it'd have to give you that, which is our identity property for a 2x2 matrix. If it was a 3x3 matrix when you multiplied, then in order for it to give us the identity, it would look like this, a 3x3 grid with ones going across and everything else zeros. So again, when multiplying, if it gives you one of those two things, then it is an inverse. All right, we're gonna stop there. And again, make sure you study for the test. And if you go back and look over this and the homework from the previous night, you should be good. I know I didn't put as much on there with the inverse last night or the determinant. So again, you may see a few more of those questions, but make sure you study and then you'll have the test tomorrow.